What I've done is I posted all of the study guides from this semester. Somebody in my first period thought it was just from like this quarter or like from this unit. No, it's the entire semester. Okay, so with that being said, please review this weekend. I updated some other things on your progress learning. I posted videos, like help videos that walk you through like how to do some of the tough problems. And then I posted another like assessments, like just practice questions. I posted this. The answer keys are also like embedded in Google Classroom. So you should not be like, oh, I don't know what to study. You have like 3 different options to start with. Okay. So I would take out a piece of paper. I'm going to go over like the topics that people ask me for specifically. So on your piece of paper, go ahead and write number 1 down. Go ahead and write number 1 down. This is going to be factoring. So for factoring, we learned that this was ax squared plus bx plus c. And you're going to identify your a, b, and c. So a is 1, b is -7, and then c is -18. Okay, the next thing that you do is you create that big X and you say a times c, which is -18, and your b value is -7. You ask yourself, what 2 numbers can I multiply together to give me -18, but add together to give me -7? And that's -9 and 2. The next step of factoring is to draw that box. Okay, so we list the first term in the first box, last term in the last box, and those 2 numbers we just found, we slap an X on them and put them inside the box. So now we're going to ask ourselves, what times what would give us what's inside the box? Okay, and that's going to be x minus 9 times x plus 2. Okay, so this is in factored form. Let's say on the EOC, you forget how to factor. You don't remember. What you can do is you can graph this, and you can graph all your answer choices, and whichever one like matches up, that is the answer. Okay, so like you don't necessarily have to know unless it's like an error analysis type question. On number 2 though, what they're doing is they don't have a C value. So what you're going to do is take out the greatest common factor. So from 4 and 100, what can you take out? 4. From x squared and x, what can you take out? X. So I'm taking 4x squared and dividing it by 4x. That gives me x. I'm taking -100x, dividing it by 4x. That gives me -25. And that's it in factored form. So if it doesn't have a C value, you take out the DCF. Okay, I want you to try number 3 and 4. On 3, though, we need to put this in standard form. So we're going to move that 2 to the other side. But can you try factoring 3 and 4? So on here, we're going to get a times c, which is 24, b, which is -10. What 2 numbers can I multiply together to get me 24, but add together to get me -10? -6 and -4. 6 times 4. Does that equal 24? Yeah, and then add together. 10 and -2. I'm sorry, you said 12 and -2. If you multiply those together, that gives you -24. Right. Oh yeah. Okay, so now we're gonna put it in a box, and that's gonna give me n squared 24, -6 in, and -4 in. It's okay if you switch those, that's fine. Because you're gonna get the same outcome on each side. So you'll have n-6 times n-4. Now, this problem says solve. So what you're going to do from here is take these and set them equal to 0. Okay, so that should give you n equals 6 and n equals 4. Well, let's say you forgot, you don't know how to do it. What you can do is you can take this equation, plug it into Desmos, and where it crosses the x-axis, that is your solution. Okay, on number 4, is there a C term? No. So what we're going to do for number 4 is we're going to take out the greatest common factor. So we're going to take out a 3x, and that's going to leave us with x minus 6. Again, If we were solving, then this would give us x equals 0 and x equals 6. Rational and irrational. This is kind of how I like to explain it. Natural numbers are the numbers that you learn in kindergarten. Okay, so it's like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then in like first and second grade, you learn about whole numbers. So like that's 0, and then bigger numbers in 10. Integers is what you learned in like 4th, 5th grade, where there's negative numbers and there's positive numbers. Okay, and then rational is where you learned about fractions. Okay, so rational numbers are whole numbers and fractions. Okay, irrational is where there's a square root, or it's numbers like pi, or numbers that continue on for a very long time. Okay, so if I had something like 1/3, is that rational or irrational? Rational, because it can be rewritten as a fraction. Okay, irrational would be something like the square root of 10, because when we plug that into our calculator, it continues on for a very long time. Does everybody understand that? Are there any questions about that? I suspect that the question on the EOC would be something like, if I have a rational plus a irrational, what would I get? So let's think about that. Give me a rational number. 1. Plus an irrational number, square root of 5, right? If I add these two together, am I going to get a rational or irrational number? Irrational. So it would be stuff like that. Now you just have to be mindful of it, because there are some like instances where you get a rational number. So for instance, if I have the square root of 2 times the square root of 2, when I multiply that together, what does that give me? Which is 2. Is that a rational or irrational number? Rational. So you just have to be mindful of those examples. Okay. A lot of people ask me, what is a sub 1? That's your first term. Your R is your rate, and that's your second number divided by your first number. And N is like the number that of like terms that we want. So what's the first term in the sequence? And then what's our rate? Well, if we take -25 and divide it by 5, what do we get? Okay. And we want the 10th term, so we're going to plug in 10 for N. Now, when you do that, you're going to get like -9,600,000 and something. There we go. You get -9,765,625. Okay. On number 2, though, is this geometric or is this arithmetic? So are we multiplying each time, or are we adding or subtracting something? How do we get to the next number? We're adding 4. What will we be multiplying by from 20 to get to 16? We wouldn't. We would be adding 4. So what's our explicit for arithmetic? Well, it's a sub 1 plus b times n minus 1. So this is our arithmetic explicit formula. No, arithmetic explicit formula. So what is your a sub 1? What's your first term? Okay. What's your common difference? What are we adding by? And then we have n minus 1. There's our explicit formula. Is this geometric or is this arithmetic? Geometric. Why? So multiplying by something each time. So it's geo. And now we're going to write the explicit form. So what's the initial? 500. And then what's the rate? 0.7, because we took 350 and we divided it by 500. And then we're going to raise it to the n minus 1. Cool? you don't have this feature where you can type mad and like type the list out. You have to do it by hand. I don't think they're going to ask you to do it. I think they're going to ask you to compare, but just in case, I got to go over like how to find it. So first you find the mean, which you're going to add up all the numbers and then divide by how many there are. Okay, so you're going to add up all those numbers and then divide by how many numbers there are. Now, you would have to do this by hand, but I'm going to do it the short way just because I'm sure. Okay. No, somebody's already out. Two people are out. So just wait for them to come back. Okay. So now, after you find the mean, you're going to make like a list of all the numbers. And you're going to take each number and subtract the mean from it. So you're going to take the mean minus the numbers. Ignore the sign. So it doesn't matter if it's positive or negative. Okay, so once you find those, you're going to add up that column. And then you're going to divide by how many numbers there are. Okay. When you do this, you're going to get 36. Now, here's the deal though. You can't do this in your Desmos calculator. You can't do it on the EOC. They restricted a couple of things. You have to know this how to do it by hand. But again, I think they're going to ask you to compare MADs between data that they give you. And remember that basketball question that was like, which one's more consistent? The smaller the MAD, the more consistent somebody is. Okay, so that's what I would look for. Okay, here's the formula sheet. So these are all the things that are given to you. There's arithmetic sequences on there as well. Okay, so I would graph this first. I would go into Desmos and go ahead and graph it. Okay, when you do this, domain is always going to be the same. Domain is always going to be the same for every exponential function. Well, how do you know if it's exponential? There is an x in the exponent. Okay, so the domain is always going to be from negative infinity to positive infinity. Always, forever, unless it's in context. Okay, now the range is what is the highest to the lowest. So how far down does this one go? It keeps going down. I just drew an arrow, guys. Come on. Negative infinity. How far up does it go? Well, it gets closer and closer to what number? 3. Notice how 3 is this number that's chilling out here on the back. 3 is also known as your horizontal asymptote. Okay. There are vertical asymptotes, but that's with different. We're not there yet. Okay. Now, transformation. You got this negative out front, the 3, and you got this 3 chilling out back. So this 3 in the back is up 3. This 3 out front is stretch of 3, and the negative is a reflection. Okay. Asymptote is where it approaches but never touches. It gets close, 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 and never touches. Okay. All right, let me go back to that other screen really quick so that we can check everything. Oh no, not this one. Okay. Other things, the y-intercept, x-intercept, and then in behavior. So let's do that. The x-intercept. So x-intercept is where it crosses the x-axis. The y-intercept is also where it crosses the y-axis. This just happens to be the same. It doesn't always have to be the same. Okay. Now in behavior. In behavior. As x is increasing, as x is approaching to the right-hand side, where is our graph going? negative infinity. So our y's are approaching negative infinity. As x is approaching negative infinity, what's happening to our y's? What are we getting closer and closer to? 3. Notice how these two numbers are what are arranged. Yes. Just a refresher on the transformations. So again, if you have something like, oh, whoops, not X. This, remember this moves you up or down. Any number that's up here moves you left or right. Remember, it's the opposite sign of what you normally would think of. This is a stretch or shrink. A shrink is less than 1. Then the negative out front is a reflection.